Hi everyone. Before moving to the video, let me explain something. As you know, when we are working in the MEP industry, we are having like four types of layouts, right? Five types of layout actually, but four main drawings like tender drawings, IFC layout. So tender and IFC has to be prepared by the consultant, and the next two shop drawing and as-built layout. Shop and as-built layout has to be prepared by the contracting company only. But what all changes the shop drawings are having within the site, we will be marking by the help of a red pen. That is called the red line layout. So by the help of red line layout only, we'll be making the as-built layout. Okay. See, when we are receiving, means in case of if you're considering the contracting company, when the contracting company is receiving the tender drawings from the consultant, most of the time the plumbing layouts, ductwork, everything will be single line drawings only. They will not be providing us two-dimensional layout most of the time at the time of tendering. Okay, IFC, they might be providing 2D. Or even if you are working within the consulting company, same, tender drawing preparation, they'll be making like a single line. Okay, but IFC, issued for construction layout, or India, we used to call that as GFC, good for construction layout, they will be making as a two-dimensional layout. Anyhow, when the contracting company is making the shop drawing, still for huge project, the plumbing layout, they will not make into like a two-dimensional layout. Still, they will keep that as a single line only. But the pipe route, that single line, they will be providing a global width value, or they might be providing a line weight. Accordingly, thickness of the single line has to be increased. Then we will be using it for construction, because for huge project and all, it is not practically possible to convert that into a two-dimensional layout. And but still, like a medium scale projects and fit out projects, we need to convert that into, if you are getting a single line IFC, we need to convert that into two-dimensional layout by the help of CAD. People there already working in the BIM field, you're already familiar, means if how you can convert that into a single line to the 2D, correct? You can simply upload the CAD file to the Revit, and after that, we can easily convert that into a two-dimensional layout. Then the same we can use for the execution, correct? But still, most of the companies are using AutoCAD only for submission. Few guys are still not familiar with the BIM process or Revit and all. For those guys, I am explaining this. So guys, they're already familiar with the CAD to BIM process or BIM to CAD process. You know everything actually, but still a lot of people were working in the fit out projects and all. They will be struggling to convert a single line piping layout into 2D layout. So how, by the help of a Revit software, we can do this work easily? Means even if your company will not be using the Revit, it is not mandatory. Your company should follow the Revit. But if you are having your own Revit in your computer, this single line to 2D piping layout, you can make it easily. How you can do that? The same only I will be going to explain in the video. Okay. Let me open a plumbing file. So this is extra attached. So let me attach the extra. Okay. And all the extra layer I'll be converting into, let's say 252, so that I can fade it. Okay. And okay, draw order, I'm sending it to back. See, this is my piping. It's a single line only. Actually, this is a shop drawing, but it is not completed yet. See, here, the thickness of the single line, we have used global width value only. Based on the global width value, we are making it. So if you want to convert this into 2D, how you can do that? Okay, normally what people will be doing. So they will be, for example, if this is a 50 mm schedule 40 pipe, for example, if it is a 50 mm schedule 40 pipe, let's say this one, they will be having the middle line. Then from there, 25 mm they will be offsetting. 25 mm they will be offsetting in the right side and left side. Accordingly, you can make it like a 2D. But when you are making the fittings and all, that will be very difficult. Also, 50 mm schedule 40 PVC plastic, it doesn't mean that. For example, if you are using UPVC or CPVC, schedule 40 50 mm, it doesn't mean that the internal diameter is 50 mm or external diameter OD is 50 mm, correct? Nominal diameter or nominal pipe size is just a represented value until 12 inch, but 14 inch onwards, nominal pipe size or diameter nominal will be representing the OD only. So that's why with respect to the center line for 50 mm schedule 40, if you are offsetting 25 mm and 25 mm, you'll be getting the external outside diameter only. So exactly the schedule 40, 50 mm, the outside diameter is not 50, that will be slightly higher. So that is wrong only. But still the people are using for easy work, no, they will be following the same method only. But also that is very time consuming process when you are making the exact fittings and all. So when the people are reading it, the single line layout and all, what type of fittings are going to come there? No, they will not be getting the exact idea when they are reading the plan. Okay. Anyhow, even if, as I told before, even if your company is using the AutoCAD for shop drawing submission, how using Revit, if you're familiar with the Revit, how using Revit, this route we can convert into a 2D easily, that I will be explaining now. Means this AutoCAD file I will be exporting into Revit now. Then I'll be converting easily this into a 2D format. Then after that, from the Revit, I will be exporting into CAD again. Then we can set the sheet and we can submit. How we can do that procedure or process? Let me explain. Okay, now we can start. See a convenient template you can select. Either you can select a mechanical default metric. Since I'm doing in metric, you can select like mechanical default metric, or you can select systems default metric or plumbing default metric. So we need to do just the plumbing. So I'm selecting plumbing default metric. So if your company is following Imperial standard, you can select Imperial as well. I'm just going to the new option, browse. I'm doing a project, so I need a plumbing default metric template. So that is project only. Click OK. Okay, so this is having like a 2 levels. Okay, anyhow, just I'm making this first plumbing as the ground level. I'm just going to the south elevation. Okay, so this is my ground floor. See, height is not mandatory here because I'm just going to do the 2D, and after that I'll be converting into the CAD. So I can witness only the plan. So height is not mandatory. So first plumbing is now at the ground floor. Okay, I'm just going to that level. And let me insert the plumbing layout. I'm just going to the insert option, link the CAD file, go to the link option. And where it is, so I have stored that in this folder, like in desktop. Okay, so it's a plumbing file. Open it, origin to origin only. So it's there. Okay, no problem. Now it is only the plumbing is coming. So since it is XREF attached, I need to attach the XREF as well. So just go to the link CAD again and XREF origin to origin, open. Okay, let me check it. I made a circle. See, this point should come here because when I'm making the drawing in AutoCAD, I made a reference circle to align. See, the XREF should come exactly this. This is my wash basin, lavatory. So this line should come exactly on the middle level. Correct. But as you know, it is not coming. So what I'm doing, I'll be selecting this one. Okay, this is my XREF architecture. I'm just unpinning this one, move it. This point should come there. So I just made a reference line for the proper alignment of architecture. Okay. So now you can see that is fine. See, the entire drawing I'm not going to make because it will take a lot of time, but I would like to make it only this clouded portion I'll be doing, only the clouded portion. Fine. Yeah, height doesn't matter. Height is not an issue. Okay. And also this elevation head, let me move it there now so that will be easy for me. This elevation head, move it up. You can move it there and you can go to south elevation. Okay, let's select the levels that we are having. Right click this levels, you can maximize 3D extent, select maximize 3D extent. So we can extend until there, no, the levels, because our file is here only. Okay. Now let me make it. See, yeah, I'm just going to the systems, pipe session, drain waste vent, the DWE fitting, pipe diameter 1 into 1 by 4. No, so I'm selecting like a 32 mm pipe. And height doesn't matter with respect to the ground level. For time being, I'll be providing 700. Okay, let's 700. Then make it like fine and realistic. So I'll be connecting up to there. Okay. And I'm just making a section because, as you know, sometimes we'll be having a bottle trap there, or a P trap or U trap can come there. Make it like fine. So that's why this connection is coming from the wash basin. So I'm just making an elbow upside so that I can witness better when I'm converting into 3D. And I need to provide, because all these three wash basin has connected to a single common pipe only. I'm selecting a pipe. Let's say the pipe is 2 inch only. See, this pipe is 2 inches. It's 50 mm. So this one I'll be placing nearly on 500 with respect to the ground floor within the wall. I'm explaining until there. Slope I am not introducing. As I told, in plan it is not mandatory, but wherever it is required, I will provide it. And also I need to align the center point of this one before that. Okay. I made a section there. Now I'm just making another section as well. Because if the center point has not properly aligned, it will be difficult. So I just made a circle, and I'm just going to here. And let me make a reference pipe for time being. This is just for alignment only. The center line of the pipes has to be aligned, otherwise it will be difficult to place. Now I'm just selecting this align. Okay, now the pipes has perfectly aligned. We can delete it. Now we can connect to trim and extend the single element. Select this one, connect it, right? The end of this 50 mm pipe you can cap, or by the help of an elbow you can provide this outside, means the face of wall. There we can provide a clean out as well to clean the pipe. Anyhow, since it is within the wall, that will be difficult. And since it has already made, just click the tab key. Okay, now you can copy the pipe. Make sure the multiple has selected. Selected. Okay, you can place it there. You can place it here as well. Fine. If it is not properly aligned, you can slightly move it, no problem, by clicking the tab key. If one point, if you want to move it, you can move. Okay. Tab key. Fine. Now we can connect that as well. So this, since we have copied, I don't want this one. Trim and extend. So this pipe we can move slightly. We can adjust that. Okay. Trim and extend single element. Select this one. Connect it there. Select this one. Connect it there. Okay. Now just split this pipe. Delete. Go to the ground level. Yeah. Now from this point, I need to connect to the floor trap. So floor trap is a family that is not available in the Revit default family set. We have to create it. We are having our own family. Let me load it. I'm just going to the system, a plumbing fixture. Family creation is very easy only. I have explained in a parametric family creation already in our video. It is available in our YouTube channel. And not only that, the same drawing, how to do this routing using IPC, drainage fixture unit and all, I have explained in on another plumbing. That video is available in plumbing designing and drafting session. You can watch that. Okay, let me load the floor trap family. Load family. So where you have saved it. Okay, so this is a family I require. Click open. See, that is not visible, no? When I'm trying to select it, none of the created elements are visible, no? The problem is view range only. So let me edit the view range. And the view depth I am providing unlimited. Apply. Okay, now you can see this is a floor trap I have placed, because before it was not visible. Rotate it using spacebar. Okay, now just aligned it. I have exactly placed this on the ground level only, ground floor. So the top of this one will come on exactly on the ground level, finished floor level. Okay, so now align this side as well. Here as well. Fine. Now this has to be connected there. Okay, select the floor trap, right click, drop pipe. It's a 50 mm. As you know, the floor trap inlet is standard, that is 50 mm only. You can connect it there. Now this has to be connected here as well. But it has to vertically come down. This pipe is located at the ground floor -72. This is with respect to the ground floor 500 only. So select this, drop pipe. It should come -72. So the elevation you can provide -72 with respect to ground floor. Then you can connect it there. Then you can connect it here. See, the connection has terminated. Done, right? I made it there. You can see that is there. Make it like fine or realistic. I made the pipe. So when you're converting this into what? 2D, That will be easy. Now this has to be connected to this shaft. The pipe is 3 inches only. Okay, anyhow, this is a flow trap outlet. Okay, and now let me make a connection. Okay, select it, create similar. I will be connecting a pipe here, and let me make it, this is 3 inch only, like 3 inches. Okay, and this should come through the shaft. Fine. So let me make a section there. Okay. See, right click, and also let me provide a slope slope value 1%, slope control point, this one, finish it. No, this should be like -1, and okay. Slope is not mandatory, but just I have provided that one. Okay, now that has to be connected here. Okay, and also let me extend a little bit. Since I have provided the slope, this slope up only 1% slope. Keep it there. How we can connect? 2-3 ways we can connect it. Anyhow, from the flow chart, 80 mm outlet I am getting. Okay, slope down only 1% slope. See, in IPC we know like horizontal drain, how much slope has to be connected. It is already there in the IPC. But since it is planned, slope is not mandatory. But for the perfect connection, I have provided the slope there. See, IPC up to 2 inch, 2.5 inch, you have to propose 1/4 inch per foot slope. For IPC, up to a 2.5 inch pipe, you should propose 1/4 inch per foot slope. So 1/4 inch per foot slope, or 1:50 slope, or then 2% slope, all are same. Pipe diameter like 3 inches to 6 inches. The slope should be like 1/8 inch per foot. Each feet of pipe length, 1/8 inch slope has to be provided, or 1:100 slope, or 1% slope, all are same. Above 6 inches means 8 inch onwards, the slope should be 1/16 inch per foot. Correct. Anyhow, here I have provided just 1:100 only, as I told, because I'm making a plan only. But slope has to be provided for the proper 3D connection. That's why I have provided. Okay, anyhow. Let me select it. Click here. It's a slope down 1% up to here. Okay. Now this has to be connected there. Select it. Okay. Directly, if you want to connect, see the pipe center point has to be connected. So you can select this one. This is having a middle elevation, or upper and top, lower and bottom, upper and central line. Okay. And the offset has to be corrected. Correct. Then only we can connect it. So either you can adjust here in the upper and top elevation, lower and bottom elevation. For example, this one that is having same pipe only 3 inches. This is having upper and top elevation -42.6. We can select this one, upper and top elevation -42.6. Both are at the same level only. Now we can directly connect it. You can go to trim and extend a single element. Select this one. Select this one. You can connect it like this. That is easy. That is one option. Otherwise, you can do one thing. Select this pipe. Okay, create similar. Then you can go to inherit elevation. Then you can make a reference pipe like this. Now, both this pipe you can align, this one and this one. And after that, you can make a small section here. You can go to this section. Okay. Now this side also you have to be aligned. So select this one, select this one. Now you can connect this one like a trim and extend corner. Select it, you can connect it. Okay. So anyways, you can. This is one type of connection. Okay, one type of connection. Or if you don't want this pipe, one more connection I can explain. I will be deleting this one. Okay. Let me join these two pipe. Now I need to make the connection. Okay, so select this one. Fine, just go to ground floor. Okay, right click, drop pipe. See, this pipe is, I have provided a slope. So since this is coming slope down, this has to come slope upside. So slope upside 1% slope, and also the middle elevation I'm providing approximately minus 500. Okay, for time being. Then I'll be making a pipe like this. Now you can see both the pipes are at how it is coming. See, from there I made a connection like this. You can witness. Correct. Like this. Means from a point I made this one, an inclined one. Now, since it is aligned, we can make a easy section there. Once again, the height, everything has to be aligned perfectly. Okay. So go to align option. Now this one and this one has to be aligned. Okay. Now you can connect it. Now both the side has aligned perfectly. Trim and extend. Select this one. Select this one here. So I made that one. That is another connection. So which connection we like, that one you can make. Okay. Previously I made one. So now I made this one. But if this connection has to be connected, before that, what connection I made, the same you have to maintain. Okay, whatever it may. Just once you have completed, see, I made a lot of sections. If these sections are not mandatory, you can select it and delete it. So once your work has completed, fine. Once it has completed for this section, what you can do, you can export it. You can export it. So I just approximately made it for your reference, only this clouded area. The remaining area also has to be done. Then this pipe has to be modified. No problem. Once it has done, you can go to the file option. Okay. Then export option. CAD format. This is very important. CAD format, DWG. And what version of AutoCAD you are using? Okay. So what all things you have to export? Okay. Everything I have to export now. Only one drawing we are having, no floor plan, ground floor. Okay. Next option. Where we have to save it, like what version you have to save, AutoCAD 2018, 13. So if you are using older one, you can provide 2010 or 13. See, I'm using 2018. And in desktop, BIM to CAD. Okay, let me make a new folder. Let me provide a name. It's 3D to 2D. Okay. Save it. Okay. Now what you can do? Just go to the folder where we have saved it. Yeah. Then BIM to CAD, open this file. You can see this is a file, 2D. See, we need to remove this center line views and all. Now the concerned layer we can turn off accordingly. Then I'm not repeating how you have to hide it. I guess that is what pipe, soil pipe only. You can hide this one. Or if you want to hide, this one was our waste route only. So waste route like that, the layer you can uncheck. Okay, so the revision cloud was in which layer? So that's a part of XRF only. So the XRF layer we can edit. It means what all things you need to hide, that you can hide it. But this was easy. Now, for example, if we are going to make this fittings and all, so that will take a lot of time. No. So now, what sheet you required as per your company reference? For example, if it is A1, means you can sheet setting. I have already explained in the drafting sessions in detail. So if your company is already having, for example, like a reference, let's say tentative sheet. Okay. So let me select it. It is an A1 sheet only. It's an A1 sheet, but this one is for HVAC only. But no problem. You can change that into plumbing. Plumbing 01. Okay. Ground floor. Let's say, for example, plumbing layer. Now this is A1. So like MV enter. And where is your drawing? And what scale you require? For example, the key plan, only this portion has to be projected perfectly. So what scale you require? For example, 3 by 4 inch to 1 feet, or like 1 feet 1 inch. So as per your convenient scale, you can plot it. And the key plan, if you want to keep it, the key plan if you want to keep it, you can keep somewhere. But key plan, it is not mandatory to scale perfectly. Only the main drawing has to. For your internal reference, if you want to keep the key plan somewhere there. And more details, we can legends everything so that I'm not repeating anything. Uh, Not only that, sometimes we are making the two-dimensional layout using AutoCAD. We might not be receiving the proper fittings. So if you are not having the fittings, you don't want to worry. By the help of Revit, we can make it. Because using the dimension, if you are making the elbow, T joint, Y joint, that will take a lot of time for each dimension. So you can do one thing. Dynamic block, most of the companies might be having. But if you're not having, what you can do, you can take the pipe. For example, 32 mm fittings if you need. Okay, you can go to the systems. You can select the pipe option. Okay. Anyhow, I'll be starting from the level itself. I'm making like a DWV fittings. Okay. Let's say it is like a 32 mm pipe. So any pipe diameter you can take. I'll be making a straight pipe. Okay. Make it like a fine. Then you can make it realistic. Fine. Okay. This 32 mm. After making it, just create similar. Okay. You can make it like this. Then you can make like a 45-degree or 60-degree. For example, I'm making a 45-degree. Again, I'm taking it straight. Then I am making like an elbow. Or if you want to get a T upside, like create similar. After clicking here, let me provide an offset of 500 mm. Then I can make it like this. Okay. So necessary fittings. This is 32 mm. So I'm just deleting all the pipes. We can delete the pipes. So the necessary like fittings you can keep in somewhere. Okay, this is for 32 mm. Okay, let me move it. I guess there is some fittings. Okay, just above we are having fittings for that. We have to remove it now, so that's why it's like fine. Okay, delete it, and we can move it there. See, like now you can take like what 40 mm. Or if you need 40 mm, you can go to the pipe section. You can take 40 mm. Okay, make the pipes, select it, create similar. Okay, you can make it there, keep it like a 45. Then you can make it straight. You can take it like, so what all fittings you need? Okay, void, T-joint, trap if you need it, traps. Now once it has done, you can do one thing, you can go to the file. Okay, then you can go to the export section, CAD format, DWG. You can save this. In a drawing, you can save it. Let me save it like the fittings, 32 mm and 40 mm. Save it there. Okay, then we can open that in CAD file. So this one you can copy, correct. This you'll be receiving like a block. This one you can copy in your drawing. So as per your requirement, if you want to make it, no, you can make the pipe now. Anyhow, so this fittings you can use for your two-dimensional layout preparation. So that will be easy, correct. So these kind of tips will help. See, now you can go to the Control P, continue to plot, preview. Yeah, line thickness is plotting now. So make sure the object plot line object has unpicked. Now you can use for submission, right? See, initially, since I am explaining initially, it may take some time, but once you're familiar with this, even if your company is not using Revit, but if you're having Revit in you're having sufficient knowledge of Revit, you don't want like a master like level knowledge in Revit, a very minimum knowledge if you're having in Revit, what you can do, if you are getting like, as you know, when you're working in the fit out companies, like we might not be getting that much time. Just one day you might be getting to submit the shop drawings. Sometimes you have to submit within 1 or 2 hours. Correct. So we will not be having that much time on that time to make it like a 2D layout and all. So you can, even if the companies are not following it, you can simply upload that in your own computer. Then you can convert that into 2D. Then you can convert You export that into CAD, then you can submit like this. Only the simple sheet setting has to be completed. You can submit like this. Hope this helped. And I guess most of the people might be aware about this, but those who are, because few of my students were working in fit out projects. We already made a video before, but just for anyone can watch. That's why I made this video. Hope this helps for everyone. Thank you.